Example 9 is talking about negative angles, and it wants us to express each of the following in terms of the same trigonometric function, but of an acute angle. So let's look at our first one. So it says the sine of negative 52 degrees. So what a negative angle means is that it's going to be counting backwards instead of forwards. So for example, if I start at 0 and go forward, I get to 360. Now, if I were to count backwards, I'm at negative 360. These are the same, they're all in the same place. They all end on that, right side of the x-axis. They all end there. They all have the same properties there. And so moving forward and backward is something that we can kind of do. Now, what we want to think of is how far away is that angle? Can we make it work? Is it within one rotation one way or the other? If it's within one rotation one way or the other, it becomes a lot easier to understand. So our first one, the sine of negative 52 degrees, well, 52 degrees is a pretty small angle. So what we're doing is we're going backwards 52 degrees. And so we're going backwards 52 instead of going forward 52. So what is the property of sine here? So sine here is about our y-coordinate. This is a negative y-coordinate. So the sine is going to be negative going backwards 52 degrees. Now, what happens if we were to go forward? Right? So our y value is going to be the same up here. Or it's going to be the opposite, excuse me. Our sine's opposite going that way. Now, how do these relate? Well, if we think going forward 52 is going to give us the opposite value of sine. So, like the sine of negative 52 degrees happens to be the same as the opposite of the sine of 52, regular 52 degrees. Because if we think about it, we're starting, so think about this picture. If we start at 0 and add 52, or subtract 52, look at what the y-coordinates are doing. They're opposite, right? The y-coordinates are actually opposite of each other. So we can always count on that. And so since 52 was small, we could do that very quickly. So that is our final answer for there. Now the next problem says, okay, so what about the tangent of negative 26 pi over 5? Ugh. So that is kind of ugly. So think back to our last problem where we were dealing with really large angles that are kind of far out there. Well, negative 26 pi over 5 is, so think about the negative 26 over 5 part. That's like close to negative 5. So we normally do 0, 2 pi, 4 pi, etc. Well, we could also think of that as 0, negative 2 pi, negative 4 pi going back. So we're going back quite a bit. And so what we want to do is make sure that we get an angle that's at least either in within 2 pi of 0 or between 0 and 2 pi. We want to make sure it's in that area. So we start off with negative 26 pi over 5. So what we need to do is, because it's negative, we need to add. Right? We need to get closer to 0. So we're going to add 2 pi to this. Now, if we're talking about 5s, 2 pi is going to be 10 pi over 5. So that gives me negative 16 pi over 5. Again, that is too big. That's too far from 0. So I'm going to do the same thing again. And I'm going to get negative 6 pi over 5. Okay, so that is something that I can kind of deal with. So let's go ahead and just deal with negative 6 pi over 5. We could also add 10 pi over 5 again to get to 4 pi over 5. That's something we can also do. But we can deal with negative 6 pi over 5 as well because it's within one swing for us. So let's start with that angle there. So that's got the same properties as negative 26 pi over 5. It's very nice. So if you think of negative 6 pi over 5, that is going to be starting at, oops, it's going to be starting at 0 and going backwards 6 pi over 5. So remember, 6/5 is bigger than 1, so it's going to go more than halfway around. So this is negative 6 pi over 5. So what we want to think is, how can I get an angle that has the same sort of relationship with tangent in the first quadrant? So what if I said, okay, well, remember, tangent is y over x. So in this quadrant, in the yellow, I've got a positive y and a negative x. So that's a negative tangent. In the first quadrant, by drawing where I did, it's going to be a positive y and a positive x. So it's a positive tangent. So how do these things sort of work together? How do they do that? So let's take a look. So negative 6 pi, so these angles share something in common. They both seem to be moving backwards off this line the same amount. Well, how much are they moving off of that line? Okay, so negative 6 pi over 5, this line over here, now we normally call that pi, but it's also negative pi too, because if we think about going backwards pi, that's where we went. So we're going to think of this in terms of negative pi. So if we think of in terms of negative pi, I can tell you, okay, so that the tangent, of negative 6 pi over 5, okay, is the same thing as the tangent of negative pi minus what angle? So if I have negative 1 and I get to negative 6/5, think of that 1 again as negative, or that negative 1 as negative 5 over 5. I'm actually going to be taking away pi over 5. Right? Because a whole minus a fifth makes 6/5. So this is my reference angle. This is the angle here, this pi over 5, that I'm going to be looking for, because I'm backing up pi over 5. Because I moved to the other side, and because I had a negative tangent over here and a positive tangent over here, this is going to be the opposite of the tangent of pi over 5. So we can kind of move forward and backward and make relationships to these angles as we move along. Now, if you had moved from negative 6 pi over 5 to 4 pi over 5, you could have also gotten to the same sort of place that way. But this way, we can also get to the same thing. And it does make something very nice that we can kind of relate the two things together.